Laplace transform of small assay of x function. So first of all, let me just give a brief introduction about small assay of x function if you just don't know it, in case if you don't know it. So this is defined as negative of the integral from g to infinity of sine t, if here's g, here it should also be g. I'm sorry for that, it should be g. Sine of g, SA of g is negative of integral from g to infinity of sine x by x dx. Yeah, and the negative sign over here is because so that the derivative of the SA function will just be sine g by g. Yeah, if it was not here, if the negative sign would not have been here, here would have been negative sign, so that's why this is already here to avoid the ambiguity. Now let's proceed with the solution. Now also please know that the Laplace transform of sine from sine at, Laplace transform of sine at, yeah, is just a by s square plus a square. Yes, and Laplace transform is basically just the integral from 0 to infinity of e to the power minus st f of t dt. Please know these things in your mind before we solve the problem. Now we are good to go. Yes, let me just try to make this ink a bit thinner, and let me write it in a proper way, because this doesn't really look nice to me, at least to me. SIG. Yes, now it's good. Now to solve the problem, we will just use the integral definition of SA function. Integral from 0 to infinity e to the power minus alpha x, and the integral from x to infinity with a negative sign over here. Yes, and then SA of x is sine t by t dt. Yes, now if we make a substitution, let's say y equals to t by x, then the limits will change to numbers, and that is helpful. Integral from 0 to infinity e to the power minus alpha x. Now integral from 1 to infinity, sine of t is sine of xy, t is xy, and dt is x dy. And I also forgot dx over here. Yes, just a dx. Now next thing is we can see that the x cancels it out. Also, we will try to interchange the integrals, because most of the time if we interchange the order of integral, the integral simplifies, and so in this case as well. E to the power minus alpha x sine xy by y, and if we interchange the order of integral, dy dx becomes dx dy now. Yes, and now since this inside integral is in the world of x, y is just a constant. Yeah, so we can deal in the same way by knowing that y is a constant. And from that we get that using the formula of Laplace transform that I said earlier, this is just y by alpha square plus y square dy. Now you can notice that y cancels out, so that's why we have minus 1 by alpha tan inverse y by alpha. This is the standard formula that we learned in high school. And next we have minus 1 by alpha. This is just pi by 2 minus tan inverse 1 by alpha. Yes, and we know that tan inverse 1 by alpha is just cot inverse alpha, so we have minus 1 by alpha pi by 2 minus cot inverse alpha. Yes, and then now pi by 2 minus cot inverse alpha is again just tan inverse alpha. So the final answer is minus tan inverse alpha by alpha, or in other way minus arctan alpha by alpha is the solution. Yes, the flow was to use the integral definition and then change the limits to numbers, interchange the order of integral, use Laplace transform, and get the answer. So that was it. It was pretty simple, but hope you enjoyed the video. Thanks for watching, and look forward to seeing the upcoming videos too.